Hello and good day. We are in pre-algebra going over the answers to PO10, multiplying and dividing integers and fractions before we get into CO11, which is our objective for today. So we filled out this chart last week on Thursday, and we learned about looking at the signs of your numbers to determine what the sign of your answer is going to be. If both signs are the same, either both positive or both negative, it's going to be positive. And if they're different, then it's going to be a negative product or quotient. So just going over answers here. 8 times negative 3 is negative 24. Next one's positive 20, negative 60, negative 2, negative 9, positive 6. Okay. I use a couple different ways to show that we're multiplying here. Note that that dot, as well as just two numbers separated by parentheses there, both of those are ways to show that you are multiplying. Okay. Second row, positive 8, positive 5, 33, 6, negative 21, and negative 6. Okay. Any questions on those 12? Again, you will not be able to use a calculator on this test. Obviously, I'm not interested to see if you can, type those in correctly and everything. So you will need to know the rules for signs when it comes to test day. With fractions, let me open up to my answer key here. They do need to be in symbols form. So this one should be negative 2/3. If you have negative 30 45ths, then the error was just not simplifying. Can you sit flat, please? Thank you. Next one, we've got 95 81st. I believe that one was done together as well. Positive 11 sevenths. Then negative 15 28ths. If you have negative 30 56ths, then it was not simplifying. And the last one in this row is 16 21sts. If you have 48 63rds, then you should have simplified down to 16 over 21. Second row, anything divided by itself is 1, including a fraction. So 1/2 divided by 1/2 is just 1 whole. Then we've got 63 over 80. Negative 11 15ths, 1/2, and negative 16 27ths. Any of those you'd like to talk about in more detail? Want me to go through the work, see how it's done? Going once, going twice, going thrice. Yes, price. Haha. For the 1/2 divided by 1/2. Yeah, if you've got 2 over 2, technically that does simplify to be 1 whole because you can write it as 1 over 1. So 1 whole should be the answer that you have there. They have the same value, but if we want to put it in simplest form, which we do, then 1 should be what you get. Good question. Any others? All right. Put PO10 away, and we will move on to CO11. CO11, probably one of my favorite math concepts to teach here. Okay, and we were talking about the order of operations, right? So in my best movie voice, imagine a world without rules for solving equations. In such a world, 3 plus 4 times 7 could equal 49 or 31. It's pretty good. This would be a problem if we didn't have rules for solving equations, right? Because it would be chaotic. Math being a universal language in the sense that anywhere you go, 2 objects and 2 more objects would make 4, right? Now that number 4 might be said differently or might be written differently, but the value of 4 is the same wherever you go. And so if we have different values for the same equation, that would be problematic. Yes? Sure. Okay. And so when this was kind of realized, okay, I mean, you can't just look at this and say, today I want to add 3 and 4 first to get 7, and then multiply that by 7 to get 49. But maybe tomorrow I'll multiply 4 and 7 first to get 28, and then add 3 to get 31. So which equation is correct? Does 3 plus 4 times 7 equal 49? Or does 3 plus 4 times 7 equal 31? 8 equals 31. Okay? And the reason why we multiply first is because of the order of operations. Who can run down the order of operations for me? I'm confident you've heard of it before. Aiden?
Parentheses. Forgot what the E was. The R is like ratio.
You were taught the R? Oh, bless my heart. That is awesome. You were never taught the R? PEMDAS? Well, yeah, there are two types of people in the world. There are PEMDAS people and there are PERMDAS people. And studies have shown PERMDAS people are just happier. I made that up, but okay. But yeah, yes. Leah. Go for it. You're close. You got all of them but the R. Ratio isn't actually an operation. It's a math word, right? It's not like you said, parentheses, exponents, and rock or something like that. So you're in the right ballpark there, yeah? Sorry? Roots is correct, yes. So the order of operations, we will start with parentheses. That's at the top. Parentheses are kings. Okay, and really, you could make the argument that parentheses aren't an operation either. You can't say like, I'm going to parenthesize 4 and 5. That doesn't really make any sense. But it's a grouping symbol that allows us to change the order of operations. And I'll get into what that means in just a little bit. Next comes E, which is for exponents. We've talked about those before. Then comes the R, which is for roots, also called radicals. We'll get more in depth with those tomorrow. And then we have multiplication, division, addition, and subtraction. PERMDAS. Okay? Now, where people do get into trouble, because everybody, your parents, if you go home and mention the order of operations, they'll probably say PEMDAS or PERMDAS or something like that. But where people get into trouble is they think that this is the literal order. Every single time you come across an equation, you must do the operations in this exact order. That's actually not true. Okay? There are different levels to this, and so we can kind of put a separator between division and addition, between roots and multiplication, and then up between parentheses and exponents. Okay, so the operations of addition and subtraction are kind of grouped together. Multiplication, division grouped together. Exponents and roots grouped together. Why will these operations be grouped in such a way? What's the relationship between addition and subtraction? That is also true for multiplication and division, and also true for exponents and roots. Maggie? They're opposites, right? Addition and subtraction are opposite. And so if you have an equation that looks like this, if we have 10 minus 6 plus 3, okay, it would be incorrect to do addition first here. It'd be incorrect to rewrite this to be 10 minus 9 and have that equal 1. Right? Because addition and subtraction are opposites, they're on the same level here, and they're the only operations we have in the equation, what would we do? What would we do? Aiden?
See which one comes before the other one?
Well, that's kind of what we just said gets us into trouble here. Because 10 minus 6 plus 3 does not equal 1. And 6 plus 3, if I'm interpreting your answer correctly, when you say see which one comes before the other one, what do you mean? Maybe I should dive in a little deeper.
I mean, what do you think?
Okay, so yeah, we would not add here first. Okay? When the operations that we have are in the same level, you just work from left to right. So it would be correct to subtract 10 and 6 to get 4, and then add 3 to get 7. Okay? So and that's why I put these dividers here. If the operations that you have, and then all that's left are on the same level, right, the same group, then you just work from left to right. Okay? Work from left to right. Questions so far? Yvonne?
So, like how you separated them, if they're the opposites, you can just do it from left to right?
Right. Correct. Okay, you'd work from left to right. So another example here, if we had 12 divided by 4, and we're multiplying that by 6, okay, we would not multiply 4 and 6 first, even though in the order of operations, M comes before D, right? It'd be just as correct to call this perdmaz. Okay, put the D before M. And the reason why we can do that is because they're opposite operations. They're part of the same group. So you look at this equation and you say, okay, I don't have any parentheses, don't have any exponents, don't have any roots. There's no addition or subtraction. All I'm working with are operations that are right here, which means you work from left to right. Okay, 12 divided by 4 is 3. 3 times 6 is 18. If you have something like we had in the example up here, where you've got addition and then you're multiplying, in this case, you would have to multiply first because multiplication is on a whole different level than adding is. So up here, Aiden told us that this equation is correct. We would multiply 4 and 7 first to get 28, and then add the 3 to get 31. What could we do to this equation to make it equal 49, though? If we want 3 plus 4 times 7 to be 49, what would we have to add to that equation to make that happen? Aiden. Parentheses. And we would put parentheses around the 3 and the 4 to say, okay, typically we would multiply by 4 and 7 first, but in this case, I want to actually add first. And so the parentheses kind of trump everything else. Okay? We would add first to get 7, and then multiply by 7 to bring us to 49. Right? So, down in the examples here, okay, where you get to do a little bit of practice. I didn't leave you this much space just so you could write your answer really, really big. Okay? I don't even know if that's the correct answer, but no, I left you that much space so that you can show each step as you work through these. Okay? 12 plus 4 times 3 plus 2. What are we doing first? What are we doing first? John?
12 plus 4.
We're not going to add first because we've got addition, multiplication, and then addition. Right? I'll put permdas on the side here. You know, multiplication is on a whole nother level than adding is, right? It's not one of those situations where we work from left to right because multiplication is a step above. So we have to do that first. So what I would like to see on your page is underlining the 4 times 3 to show that you're doing that step first, and then rewriting the equation to be 12 plus 12 plus 2. Okay? If you're comparing addition and multiplication, you have to multiply first. Right? And 4 times 3 being 12, now we can add these three numbers together, and so then your answer would be 26. So you can still write your answer big if you want to, but I do need to see that work. It does say to check your answer with a calculator. You will not be able to use a calculator on this section of the test, but if you type in 12 plus 4 times 3 plus 2, your calculator, being a computer, being a machine, it's going to do the correct order of operations automatically, and you will get 26. So the calculator, a great tool. Type this in exactly as you see it to get the value. Okay. Let's look at the next one. 2 plus 4 squared. What are we doing first? 2 plus 4 to the power of 2. The operations that we have are addition and then an exponents. What's going to be done first, Maggie? The exponents. Okay, so you're going to underline that. What is 4 squared? G. 16. Thanks for not saying 8. Every so often, an exponent gets thought of as 4 times 2. But if we'd wanted 4 times 2, we'd have written 4 times 2, right? That is clearly 4 squared, 4 times 4, which is 16. And now that we've taken care of that, now we can add them. And 2 plus 16, we get 18 as an answer. Okay? Pick another one you'd like to do together. Either row. One that looks particularly fun. Yeah, smart. Top row, third one, fourth one, fifth one, bottom row, first, second, third, fourth. Top row, fourth one. 5 plus 7, parentheses squared. Okay. So in this case, we've got in parentheses 5 plus 7. We're squaring that, and then we're multiplying by 6. That exponent on the outside of the parentheses, okay, means that we have to do the parentheses first, and then square whatever comes out. Right? So it's not just attached to the 7 there. It's attached to the sum of 5 and 7. So parentheses will be done before anything else. We'll underline the 5 plus 7. Rewrite that as 12. And now that we've done the parentheses, they go away, right? We can take them out. Well, what would we do next here? We now have 12 squared times 6. What would come next? Connor? I mean, multiply. Okay, so first we do the exponent, right? Before we can multiply, we have to figure out what 12 squared is, which is not 24. Okay, 12 squared is not the same thing as 12 times 2. 12 squared is 12 times 12, which is 144. Right, so we're going to underline that. 12 squared, 144. And now we can multiply 144 times 6. And what do we get from that? 864, that sounds about right. Okay. Another one to do, either row. Bryce. Top row, third one. 20 divided by 4 times 3 plus 2. I'm glad you picked this one here. Okay. So we've got the parentheses. So we've got to do that first. Okay. Nothing else matters. 3 plus 2 is 5. So we can rewrite this to be 20 divided by 4 times 5. And we know that we're multiplying 4 and 5 together because those parentheses, like we saw in PO9, parentheses are a way to show that you're multiplying two numbers together, right? If you wanted to write this as 20 divided by 4 and keep that 5 in parentheses, that would mean the same thing that I've got written there. Now we look at this and we see that we've got division and multiplication. And we refer to the order of operations and we say, okay, division and multiplication, they're both on the same level here, right? They're in the same group, which means they are interchangeable in the sense that we would not multiply 4 and 5 first. When they're on the same level, we work from left to right. Okay? So we would divide 20 and 4 first to get 5, and then multiply that 5 by the 5 we got from the 3 plus 2, and that would give us 25. Okay? So it's really a matter of paying attention to what operations you have and where they are in the order. Operations that are on different levels, your choice is very clear. You've got parentheses, your choice is very clear. But when you've got only multiplication and division or only addition and subtraction, then you've got to recognize, okay, in this case, I'm going from left to right. Bottom row, any of those seem particularly intimidating? Pierce?
Do one on the very bottom of the page.
We'll get to that. I'm going to do one more in this section, then we'll get down to that one. Okay. Yeah, Annika. Second one, 17 plus 9 divided by 3 minus 4 times 15. Oof. Okay. So what operations do we have here? We've got addition, division, subtraction, and we are multiplying. What gets done first? What gets done first? Yeah. Okay. I'm going to multiply, and that gives me 17 plus 9 divided by 3 minus 60, which is 4 times 15. What do I do next? I've got addition, division, subtraction. G? Division. Yep. That gives me 17 plus 9 divided by 3 equals 3 minus 60. Okay. Sometimes it helps. I've had folks in the past, it helps them to keep track of everything. When you underline the step that you're going to do, draw like a little triangle, makes like a little arrow, so you remember where that 60 came from, right? 9 divided by 3 equals 3, kind of where that 3 came from. It came from that 9 divided by 3. 4 times 3 gives us 12. 4 squared. So if it helps you, great, but it's not required. Just kind of help remember where each thing came from. But now I've got addition and subtraction. They're on the same level. I go from left to right. So 17 plus 3 gives me 20. I'll draw the triangle here. Right? 20, and then 20 minus 60 equals negative 40 as an answer. Okay. That bottom section there that Pierce asked about, it says it's possible for each expression below to equal 30, but not as they are written. Okay. If we look at this first one, 5 plus 5 times 3, using the order of operations, we'd multiply first. 5 times 3 is 15, and 5 plus 15 is 20, not 30. Okay, so it's possible for each one to equal 30, but not as they are written. So your job is to add parentheses where necessary to change the order of operations so that they do equal 30. So in 5 plus 5 times 3, how do I need to change the order of operations to make that expression equal 30? Carly? Where? Right. If I want this to equal 30, I've got to add 5 and 5 first, instead of multiplying 5 and 3 first. But the only way I can do that, mathematically, is to put parentheses around the 5 and 5. Because now this expression says 5 plus 5, which is 10, 10 times 3 will equal 30. Okay? So your job in that bottom section there is to put parentheses where necessary to change the given order of operations, the way it's written, so that instead the expression will equal 30. Does that make sense? Okay. Your homework for tomorrow is to finish the page. Okay. You've got 4 that we didn't do up top and 4 in the second section. Really be thinking about the order, folks. Really pay attention to the operations you have. Is it a situation where one kind of outranks the other? It has to come first. Or is it a situation where you just work from left to right? Okay. Questions, comments, concerns, complaints, comments, congratulations, or criticisms on this? Maggie?
So on the first one on the second row,
Yeah.
would you do 2 plus whatever the exponent is?
Right. So in the second one, in the first one, second row, your first step, since that exponent is inside of the parentheses, we have to do the parentheses first, but within the parentheses, we've got addition, and then we have a power. So that power would need to happen first. What is 2 cubed, or 2 to the third? Anyone know? 2 times 2 times 2?
12.
It's actually 8. Okay, 2 times 2 times 2 would be 8. And so we would rewrite this expression to be 2 plus 8, and then we would finish out doing the parentheses first. Okay? All right, folks, that is how you math.